Hello, Simon here, and today we talk about thin ink. Um, One spoiler, we will talk about the simulation of a particle system which is affected by simulated smoke. We will also talk a little bit about rendering, but I was not able to achieve such good results as this one here, because here everything looks perfect. That's actually interesting. This result I get, right, where you still have a lot of noise and stuff happens. What I don't understand so far is, and also this description down here in the video didn't help much, how they get from this to this. Because here you don't see any grain, you don't see any particles, everything is perfectly smooth. My guess is it's not rendered in Houdini, and they use motion flow vectors or something to blur that. They give some information about the p-scale and the amount. This is 705 million particles, but even with higher numbers I don't get this good result. So if you are a rendering pro, feel free to write in the comments and give us some tips. And also in the description of this video you will find a little index where you can jump to different topics, which will be like how to simulate that, and then how to render the motion blur with one way, just by the standard motion blur with Mantra, and then also how to do motion blur with comps, which will work but will not be good. Will not look good. Anyway, let's start here, and yeah, I will create a new file. Okay, so we will start by sparse pyro, billowy smoke, nothing special here, and then click the sparse pyro billow thing, click it to 000 and set the timeline to 60 frames, and then we should see some simulation here of some smoke. So that's easy. These nodes here are automatically generated, and the only thing I will do here is I go into the import, and I will create a file cache node so that we don't have to resimulate this all the time, and call it file cache smoke, and then make out smoke. So here we have our little vector field, which, by the way, here load from disk, save to disk. We have to save this whole thing, of course, and this is perfectly set up already. You will see that here we are importing the velocity already, so everything is good, and now we can scrub through the timeline and we will see this. So perfect. What we'll have to do now is create some particles and then move those particles with those smoke velocities. So in the source, smoke source, I just copy the create density pyro node, because what this does is it creates particles for us, or points basically, and that's exactly what we want. That goes out, particles. That's good. And here we will later control how many we want, but that's for later. Right now we just create a dot network. We call it particle sim, and in here we create a pop solver, and then a pop object, and then a pop source. And the pop source is of course our just created source from smoke source out particles, and then we should already see something, but we have to change this value from scatter onto surfaces to all points. So all our points we created in the source. So here in our source we create some points, and all of them are imported into the simulation every frame and simulated. Problem is, right now there's not much simulation to do, but now we can advect these things by, or these particles by pop advect by volume. And the volume we already have. This is the smoke, and where is it? Here, smoke source, smoke import. I created this out smoke null thingy, and now we should already see something, because yeah. And I was thinking, oh cool, I'm done now. But I was not realizing that there's a very important thing here. Instead of updating force, you have to update velocity in this node, because now the particles will move very nicely. This looks like thin ink. So this step is really easy or really quick to do so far. Save, and yeah, so that's something nice. And now the problems will start. One thing though I would like to mention. At the beginning, I was using not too many points here, like maybe like so. Okay, we don't have many points we spawn from. I hope you can see this here. There are not too many points. And I was like, oh yeah, that's good for performance, having less points or something. And then in here, what I was doing, instead of using all points, so all the points are imported every frame. This will look like this. We have not many anymore because, as you see, only from the points you supply, new particles are generated. And instead of all points, I used points. And when you do this, you get in birth these attributes. You don't have this when this is set to all points. Yeah, it's grayed out. So if you set this to points, go to birth, and then I was increasing the constant birth rate. And I was wondering, why don't I see more particles? You know, you can set this to very high values here, simulate that, and you will see that there are not more points than before. And if you look in the solver, you see that we already have 1 million points, but I don't see 1 million points. And I was increasing this, and I was very confused. And the reason is that there are not enough points to spawn from. And you can see this, and it was really mind-blowing to me. I like to do, like here we importing the final smoke. I import the final particles just by an object merge from our particle simulation. So, and I hide everything else. So, and what I was doing now, I was adding a jitter, a point jitter here. And when you set this to really small values, you will see that on every point we saw before, like here, so we see some points here, actually there are many. Here you see these little cubes. This means where we saw 1 point before, they are actually, I don't know, 50 or something. And this is because we don't have enough spawn positions, and so all the particles I force into the system, which are many, many more than we have spawn positions available, are spawned on the same position. So we actually have 1 million. So let's see, we see that there are not too many points here, but when I increase now the available points we have, and then go in here again and resimulate, it should look way denser. Look at this. This is the actually amount of points we have in the system, but before many of those were stuck at the same simulated positions. So that's something to notice. But we will not have a big problem with that, because now I would like to set it to all points, and instead of filling more and more ink over time, I type in here $f smaller 2, which means only at the first frame this activation will be at 1, and then it will be 2, which means that we only put in one time a little bit of ink, and instead of it's like you just put in one drop of ink into the water instead of having the more and more ink over time. I don't know what these points are down here, but if you go out of the well, let me see, out of the system, they should disappear. Why do I still see them? I'm not sure. We will see if we see them later in the final rendering as well. I don't know why they don't disappear. Because I set this to hide other objects, right? Okay. We will see how this works out. Okay, anyway. Now what we can do our first rendering by creating a camera, control clicking on the camera. I like to set it to a square dimension, boop, and do something like this. And then we can go render view, camera 1, render. let's see. This is not what we, this is my last rendering, and it was very grainy, as you can see. Okay, so here we see a little alien hive, and what I like to do now after the simulation, so here the simulation happens, and then here we import the result of that. I like to use a point wrangle to change some of the values, and one value is of course p scale. This is the scale of the particles, and you can set it to a very small value, and then you should not see these big bubbles here. And actually when we look here in this example, we see that they use very small values, so I will just use this as well and hope that we get good results. So yeah, so here we are, we have a very grainy result, and the first thing you can do to improve that is of course use more particles. And what I like is that since we only importing our particles once at the beginning of the frame, we can now control that amount of particles very, very nicely. We just have to use, we just have to change this particle separation. Now we have 31,000, and if we go further down, now we have 250,000, and now we have 2 million. Let's say 2 million. That's nice. For this other example, they used 705 million. But even with using more, I couldn't get very nice results. So for this example, maybe 2 million are okay, then the simulation is actually a bit faster. So I just go to 60 frames and let's render this now. Like I said, even with more particles than 7 million, I couldn't get to the smooth result in the video. So if you are a rendering expert in Houdini and Mantra, it would be very nice to hear how to improve that. What we see now is that we get some very wide areas, and you can change that by setting the alpha to smaller values, alpha with a big A at the beginning, and then we should get a nicer result. Yeah, here now it gets a bit more wispy, and that's very nice actually. Maybe the values could be a bit lower, but yeah, especially if you zoom out a little bit and you don't see the graininess, it already looks quite wispy, really nice. The problem is, like I said, I didn't find a way to remove the graininess. One way, of course, could be to use motion blur. And the motion blur, this is not very intuitive, but you have to go to your little particle node you're actually rendering, and then here you go into, just click it, and then you go to render, and then where was it, sampling, and then you set it to velocity blur. But this is not enough, because this would be intuitive. No, we have also to enable it in the mantra node in rendering allow motion blur. Now we have it, and it's usually a bit subtle, so what I like to do is in here in our point wrangle, I set the velocity by multiply equal sign to, let's say, 10 times of the actually velocity, just to see if it actually works, the motion blur. I like to use higher values, and just to make sure it actually works, and then you can use lower values. And yeah, I think it worked. And let's make it like this. First I will set the value to 0, and then we can use the mantra node and render this to mplay, so that we can compare the results of the rendering. And maybe, where's my mplay? It takes quite long. Is it here? No. Now we see it. Okay, let's see how this works. So this is now without motion blur, and we see, I mean, it's quite okay-ish, but I really would like to have it as perfect as in the example. And now we rendered with 10 times motion blur. Render to mplay. and then we can compare the results. So now, come on, it takes so much time. Does it even start? Ah, and now we get this window in the window. It's so confusing all the time. I think you have to press this button. Yeah, we see already that it works. We get some smoother results here. Of course, it's too much now with 10 times the speed. But my problem is that there are particles which are slower or not moving at all, and those don't get motion blur, which is logical, but they still keep their graininess. So even if these faster particles here get nice and smooth, I mean smooth air, there's even a lot of noise here, but the slower moving particles are still a problem. And by the way, I also tried this AI denoising in composite, but this looked to me more like a normal blur. Just when I add a normal blur, the difference was not very good, to be honest. So I think we can abort this here because this is too much now. This is not it's not looking very nice, but we can see the difference here, of course. No, so and I can just use the normal speed and render this to M-play. This should also be a little bit faster. But I'm not convinced, to be honest, about this motion blur. But in a second I will show you how to use motion blur in composite view or in comps, and it's also not really good. Okay, here we already see this is better. So this is the original, and this is when we just use standard motion blur with the real velocity, and this is nice. Adds a lot of motion to it, but like I said, some of the areas here, the particles are too slow and they are not enough, and then it's still grainy. This area is nice here, but here, yeah. And like I said, even with increasing the amount of particles, it was not, I couldn't get to perfect results. Okay, so let's now talk about the last thing, save, how to make the motion blur in comps. And for that, what you do is you can create a material, and I will use the principal shader. I hope this time it works. And what you have to do is you have to edit it, but don't worry, allow editing contents, double click. So, and in here, ignore everything. The only thing you have to create is a bind node. Then you set this to the vector here and call it V. So now we're importing the V attribute, and now we create a bind export node. Also set it to vector, also call it V, and connect V to input. So this should work now. I hope, at least. The first time it worked, the second time I tested it did not. So this should now channel the velocity from the points to the rendering. Of course, now we have to assign this material here in render to our points, which we actually are rendering. So, and in the mantra node, where is the mantra node? Out here. We have to create an image plane. It's in images, image extra planes, and then create a new one and just call it V. Okay, and I hope now this works. And then, yeah, we just render it here and see if it works. We should now see the velocities of these particles in this extra plane here. Let's see if it works. Come on. Because this plane was not there before. Yeah, now we see a colorful smoke, and this means it works. If you don't do this in the material, you don't see these values. We can just, let me just try to, we can stop the output of this, and we should, yeah, it's just black now. Would be very nice if this would be on by default. Okay, so let me stop this here. and go to the mantra node and render this to mplay again, because we need a frame we can store and then use in comps. But don't be disappointed, because it will not solve our problems. My guess is that for this amazing result here, they used an external software and used some motion flow vectors or something to interpolate the grainy results. I'm not sure. I don't have After Effects or Nuke or something, so maybe there's some special source you can add to this, but Mantra itself doesn't seem to be capable of doing that. Or maybe you have to use 70 million particles instead of only 7 like they did. I'm not sure about it. Okay, so don't worry, it should be a bit faster as soon as the core is done. We already have some motion blur in here. Maybe 1 second, what I would like to do, just to show the complete result, is to disable the motion blur we added before. I really want to compare the pure grainy result to the what we are doing in comps now. So let's see. Again, this rendering issue here. I don't know what we do with this window in the window. Yeah, now it gets grainy again. You can see that here the motion blur is disappearing, but we still keep our velocity. So that's nice. Cool. So, okay, we are done. So we now can save the frame as I don't know, test 01. So, okay. And now we can go to our composite view. We can go here to the image area, create a new image network, create a file network, and load our test. Where is it? Okay, now it works. I had to save it as EXR. I don't know why there was .pic as a default. Okay, so I saved this test as EXR from the mplay, and we see our velocity here, so everything is good, and we have a lot of grain. And what you can do now is just use the motion, what's called blur, velocity blur node, and you should see already something. It's not working here. Why is it not working? Yeah, okay. The velocity plane is P, but it should be V. And of course, the values are a bit too big. And now this is really interesting. You can use very, very small values. And yeah, I mean, sometimes it looks really interesting, like down here, but this is not the smoothing result I expect. Sometimes I also have the impression that the velocity vectors are pointing into the wrong direction, because I would expect everything to move up, but it looks like the motion blur blurs it down, so as everything would flow down. But I tested in inverting the motion vectors and it didn't help, to be honest. Also here in this area where you don't have too much motion, you still get your grainy results, so it doesn't really help here. So yeah, I think the results are interesting. I can increase the intensity a little bit here for preview. I think it's interesting to play with these values, also to use a bit higher values and just have fun with that, because it's crazy what it creates at some point if you use bigger values. I mean, yeah, it looks interesting, but it's really not what I wanted to have. This looks actually really nice, like lit from the inside. So yeah, we learned how to simulate thin ink smoke, so that's a success, I would say. But for the rendering, it's just not working. Just remember, update the velocity in the simulation and not the force. That's important. Provide enough spawn points in your source so that you see all the particles at unique positions. You can add motion blur by using the by enabling it here at the node and in Mantra, of course. Or you can channel the velocity through the material into here, into composite view, and then use the velocity blur. Nothing helps to me as much, but if you have good ideas, settings, then please share them and share them with detail. I would like to know everything, like all the Mantra details here. If you change this, I mean, like I said, you can change the pixel samples and everything, but it didn't help me. Even setting them to high values like 9 by 9, even using stochastic samples by 32 or something, nothing really helped. But if you have good settings and you get these results like here in this example, then let us know how to do that. And also if you know another solution, like, oh yeah, in Nuke this is super easy, or yeah, in After Effects it's super easy, then you can of course share those details, because here these guys shared a little bit of stuff but never answered on my question. Yeah, I would like to know how to do that better. So this is part 1. Maybe if someone tells good tips, I will make a part 2 where I can then share the new rendering tips. Bye bye.